Alcide is a full stack cloud operations platform, meaning that no matter whether you're running with multiple accounts on multiple regions using one or dozens of EKS and EKS or ECS clusters for that matter, you have a lot of moving parts running in your environment. And what you see in front of you is actually a view, a translation layer between the workloads and where are they running on the underlying infrastructure. So here specifically, I zoomed in on one of the Kubernetes clusters and think of those as EKS clusters and one of the microservices running on all the nodes on that specific cluster. And we basically provide, from one place, the ability to search, drill down, filter, all the different assets that are out there and provide deep security and visibility into the running workload. So a pretty simple example that I would like to start off with, one of the microservices. So I'll zoom in into one of the microservices. So think about, customer deploying, and here specifically, you can see our E2E continuous test running inside of one of the clusters. Mm-hmm. And you can clearly see how easy I can zoom in into that microservice. And you can see that the edges between the interactions between services that are running inside my EKS cluster and just as much services that are consumed on third parties. They can run, on other AWS customers. So here specifically, let's take an example of Slack. So you can see that you have a specific map or network information on who is the source or who is the exact pod running on my EKS cluster and which target service it connects to. And it basically provides you the same level of information across the different clusters. So let's take another example. I can zoom in on one of our Cassandra workloads. And this one is actually right now is offline, but just as much I can run other workloads. And here's another example of a Cassandra database that is basically accessed by other microservices. So you can zoom in, it's a pretty kind of easy to consume and digest microservice architectures, and it becomes extremely complex once you run with multiple. The other kind of sugarcoating that we bring into the mix is the ability to visualize Kubernetes network policy. So those are pretty powerful from the command line, but once you go into kind of, multiple rules, it becomes extremely difficult to digest and kind of understand what's going on. So let me filter down and zoom in on the specific cluster and just show you how exactly we surface the different kind of assets in the environment. So here specifically, you can see that I can click on one of the workloads. So here specifically, I selected Cassandra, which is running as a stateful set inside our cluster. And you can immediately see which network policy rules are defined on this cluster. I can hover on a rule and basically see, who are the members of this group. Specifically here, it's just Cassandra. You can see it here. I'm selecting that, but you can see that, for example, I am allowing all the different pods in the environment to actually access the specific microservice. And if I zoom in on another element, our front end, so you will be able to see that that's specifically another element that basically can access this microservice. So think about it as a way to kind of visualize and stay in control in every change that happens in the environment. And we provide both kind of meaningful experience for DevOps and to the shared responsibility model. So we do provide network security monitoring on top of the environment. So if I'm just clicking on one of the unsurprising name of attacking workload, So you can see that our security agents are detecting multiple network attacks, and some of them are trying to actually circumvent the underlying network. And that is what we provide on top of that is actually the ability to even detect attacks that are running east-west on the same worker node in the cluster. So it may be R poisoning or IP spoofing, and those were actually used to mount attacks on memcached and recent DHCP vulnerability on Red Hat. And this is kind of where our product extremely shines. And you can see that the attacker and the target are not running specifically here on the same host, but they are running on the same cluster.